All right, we can never get enough of the domain problems because, again, so many students struggle with these. We're going to be looking at these two problems and trying to find the domain. Now, again, the two red flags in college algebra that you need to be aware of is fractions, because you can have division by zero, and then roots, even roots, like square root or fourth root or something like that. So in the first problem, right away, you should red flag we have a fraction. And in the denominator, we have our variable. Okay, so there's a possibility that the bottom could be 0. So again, the technique is that we take the denominator, and we say to ourselves, what would make this 0, or we do not want that to be 0. Now some instructors might get a little upset with me because you're not supposed to work with this not equal sign, but for these domain problems I think this is the cleanest way to do it. So we're saying when does x squared minus x minus 6 not equal to 0? So what we're going to do is notice that this is a quadratic and that we can factor it. So using your factoring techniques, hopefully you have some, what you can do is realize that this is x minus 3 times x plus 2. So if you FOILed that out, you get this. Now what we can do is say each of these factors cannot be 0. So x minus 3 cannot be 0, and x plus 2 cannot be 0. And now if we just add 3 to both sides here, you'll get x cannot be equal to 3. And here if you subtract 2 from both sides, we say x cannot be equal to negative 2. So we added 3 and we subtracted 2. So what we're saying here for our first problem is that the domain of our function is everything. We can plug anything we want into it except 3 and except negative 2. Because if we did plug those in, it would make our denominator 0. Notice that I didn't work with the numerator at all. And that's because, again, with domains, you're only concerned about when the denominator is 0, not the numerator. Okay, now in the next problem, part G, or g of x, we're again asked what's the domain. Now, do you see a fraction anywhere here? No. Do we see a root, an even root anywhere? No. So whenever you don't see those two, you pretty much are not going to have a problem. So what we can say to ourselves is that the domain of this is anything. We can plug anything we want into this. And there's a couple of ways to write that down. You can say all real numbers, right? All real numbers. You can use interval notation, say anything between negative infinity and infinity. That's any number you want. And some textbooks will use a script R to represent all real numbers. So this is the one case that we've had so far where we can plug anything in and the function is going to be able to handle it.